Okay, so here we're given a titration problem. And first we're going to read through what is written down here. And it says, a 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molarity of calcium hydroxide. What was the concentration of hydrochloric in the acid in the original solution? Okay, so first we're going to underline what is given to us and separate some important components of the problem. So we're given 75 milliliters solution of hydrochloric acid, and we have an unknown concentration of that solution. So we do not know the molarity. And then we're also given 27.3 milliliters of 0.157 molarity of calcium hydroxide. So we're given the volume and the concentration of a calcium hydroxide solution. And now we are looking for the concentration of hydrochloric acid in the original solution. So before I start anything, I'm going to write out the equation and then balance out our solution. So we have hydrochloric acid and calcium hydroxide. I'm sorry if the permanent marker is bleeding a lot. And we're gonna get as a solution calcium chloride and water. That's an L there at the end. To make this easier to balance, I prefer to write out each element that is shown on each side and write out how much there is of that element and then match it to the other side. So we have 3 hydrogens, we have 1 chloride, we have 1 calcium, and we have 2 oxygen. And on this side, we have 2 hydrogen, 1 calcium, 2 chloride, and 1 oxygen. So I'm going to start with balancing the oxygen right here. So I'm going to input a 2 here to make this a 2, and that's going to affect our hydrogen, so that's going to make us have a 4. And then over here, we already have the 2 oxygen, and we have 3 hydrogen. So if I put a 2 here, that's going to make it 4 hydrogen, and that's also going to take care of our chloride, so we'll have 2 chloride. So now we have a balanced equation. Next, I'm going to draw a picture of the solutions that we have. So here, we have our HCl, and I'm gonna go ahead and draw 2 HCl's here because we're giving 2 moles per every 1 calcium hydroxide in this reaction. So, and they're both aqueous solutions, so I'm gonna go ahead and draw them just for funsies. And so let's write out what we're given at the beginning. I'm gonna go ahead and convert this to liters. And so what you do is you divide this number by 1,000 because there is 1,000 milliliters for every 1 liter. So this divided by 1,000 will give us 0.075 liters. And we do not know the molarity, or the concentration in this case. Over here, Again, I'm going to convert this to liters right off the bat because it'll make it easier when you are solving the problem. You already have everything converted to what you need rather than trying to convert at the end where some mistakes can happen. So I'm going to go ahead and divide this by 1,000, which will give us 0.0273 liters. And then we're also given the concentration, which is 0.157 molarity. And as seen in the equation, when these are mixed together, we will get a calcium chloride and water as our products. All right, so here I rewrote the equation onto a different page, just so we have more space to solve for the rest of this problem. Now, in the original word problem, they gave us the volume and the concentration of calcium hydroxide. And so with the volume and the concentration, we can solve, if we multiply the two, we can solve for moles of that compound. So that's what we're going to do. So we have 0.0273 liters times 0.157 molarity. And that's going to give us the moles of calcium hydroxide. And so from there, we can convert the moles of calcium hydroxide to moles of hydrochloric acid. So I'm going to put this over 1 because for me it's just visually easier. So for every 1 mole of calcium hydroxide, I rewrote this, there are 2 moles of hydrochloric acid in this balanced reaction. So from there, our units are going to cancel, and this will give us the moles of hydrochloric acid. So earlier we used the volume and the concentration of calcium hydroxide to solve for the moles. Well, we can use this same equation to solve for the concentration, because now we were given the volume of hydrochloric acid at the beginning, and we just found the moles of hydrochloric acid here. So now we can plug both of those components into this equation to find concentration. So I'm going to rewrite it as concentration equals moles over total volume. So I'm going to plug in the moles of hydrochloric acid that I solved for over the 0.075 liters that was given to me at the beginning. And that will give us the concentration of hydrochloric acid, which in total should be, when you plug it into the calculator correctly, 0.1143 molarity of hydrochloric acid. Some common mistakes that a student can come across when solving this titration problem is that they don't use the balanced equation, the stoichiometry of the reaction. They immediately think, oh, well, I'm given the volume of one, and I have the volume and the concentration of the other, then I can solve for the answer by using the M1V1 equals the N2V2 equation, which you cannot use for this problem. You will get it incorrect. So you have to use the stoichiometry of the balanced equation in order to correctly solve for the concentration of hydrochloric acid in this case. Another problem that a student come across is that they don't convert their milliliters into liters. They just say the number and they'll plug it in, and they forget the fact that this equation for finding moles or concentration is using the volume in liters. Another problem that students can come across is that they input the numbers wrong into the calculator, and that can lead to a minor wrong number in their answer and can get the whole problem wrong. So please be aware of how you type it into calculator so you make sure you get the right